Hello and welcome to another video of Wise Interactive Learning. In the 5.2 exercise, we have mainly seen what is chain rule and all the questions regarding it in 5.2. But in this particular video, since we have learned what is implicit function differentiation or based on inverse trigonometric functions, the first 6 questions, we can say that these are in the variables with some kind of polynomials mixed with trigonometric. In case of first question, we have 2x plus 3y equals to sine of x, right? So we have a combination of polynomials with respect to trigonometric. So you can say that differentiation is going to be 2 plus 3 dy upon dx equals to cos of x, and you can easily simplify this as dy upon dx is going to be cos of x minus 2 everything divided by 3. So this is your going to be easiest answer. So in similar way, we are going to go through 1 to 12 questions, and we are going to do these questions just by looking at them. Now in the second question, I'll just try to rub this off. So since we have the final answer for the first question, which is going to be cos of x minus 2 everything divided by 3. Now in the second question, we can directly see that the question is very easy, and in this particular function we are going to find out that we have two y's on either side of equation, and we generally don't want this. So what can we do? We can say that 2 minus 3 y dash equals to cos of y times y dash, and from here you know that y dash is going to be nothing but 2 upon cos of y plus 3. So that's your final answer. In the third question, we have ax plus by square equals to cos of y. In this case also we are going to have different types of dy's, and we have to be careful about solving them since they are on the opposite side of equation. So you have a equals to b 2y y dash equals to minus of sine of y y dash, and here you can have y dash as equals to, so since you have y dash on the two sides, you can collect them by doing since this is 2by and plus sine of y, and this is going to be 2by plus sine of y, and in the numerator you have minus of a. So since we have not solved any of the inverse trigonometric functions directly, like we don't have enough data regarding the solutions of the inverse trigonometric functions, I'm going to tell you that for solving inverse trigonometric functions at the level of board exams or rather CBSE, you are going to necessarily have a thorough knowledge of multiple angle formulas, and we can see it directly from the question number 9. So in question number 9, it says that y equals to sine inverse of 2x plus 1 upon x square. So here you need to understand one thing, that substitution is a way to carry out substitution. So substitution is an easiest way to carry out inverse trigonometric functions. And why do I mean this? So if you put x equals to tan theta over here, so you are going to see that 2 tan theta upon 1 plus tan square theta. So this is a formula for sine of 2 theta, and you immediately know that if we convert this 2x plus 1 plus x square, this whole term is going to be easy to eliminate. So it is going to be y equals to sine inverse of, so 2 tan theta upon 1 plus tan square theta. And now you can replace this whole term by sine inverse of sine 2 theta, and you know that you can directly eliminate sine inverse and sine, which is going to give us y equals to 2 theta. And now watch carefully, what is 2 theta? So we know that theta is only individual function, which is the variable. So x we have as tan of theta, so can we say that theta is going to be tan inverse of x, isn't it? And we have directly converted the whole function from this complex over here, this complex function over here, to this function, which is y equals to tan inverse of x. And now you can easily say that y dash is equals to, we know that the answer for function if f of x is equals to tan inverse of x, we know that f dash of x is going to be 1 upon 1 plus x squared, isn't it? We have learned it in the video with inverse trigonometric function. So your final answer for y dash is equals to is going to be 2 upon 1 plus x square. Now watch carefully that since we have known the exact formula for multiple angles, which is over here, so which is x equals to tan theta as a substitution, and then you know that 2 tan theta plus 1 plus tan square theta is going to be 2 theta. It has necessarily drawn us to a level where we can simplify the same question to such an easy term, which is 2 tan inverse of x. In the same way, we are going to see what are the different substitutions in question number 10, 11, 12 in this particular exercise. So I'll just try to rub this off. So in case of 11th question, what we can say is 1 minus x square upon 1 plus x square is the inside function of cos inverse, right? So we necessarily want to eliminate this function, this total function, and we know that immediately 1 minus tan square theta upon 1 plus tan square theta is nothing but cos of 2 theta, isn't it? Since we know the multiple angle formulas, so we can say that x is nothing but substitution tan of theta, and immediately theta is equals to tan inverse of x, isn't it? So when you put 1 minus tan square theta upon 1 plus tan square theta, you have cos inverse of cos of 2 theta, isn't it? And then this cos inverse and cos necessarily will obviously get eliminated, and you have 2 theta, which is nothing but 2 tan inverse of x. And since you know y equals to 2 tan inverse of x, you will easily be able to find out what is the answer for y dash. So in the similar case, the question from 11 and 12, if you look over here, the inside function, so watch carefully over here. So the inside function over here, which is 1 minus x square upon 1 plus x square, for 11th and 12th question, they are same, but the outside function, which is sine inverse and cos inverse, those are different. So then how do we understand that? How do we are going to solve this question? So this is an easy trick or easy way to tackle this question, which is nothing but understanding what is cos inverse of x plus sine inverse of x, which is nothing but pi upon 2. So now if you look at this particular question, what you are going to substitute is same. So you are going to substitute x equals to tan theta for the 12th question also, and inside what you are going to get is, so I'll just try to write in blue. So inside what you are going to have is sine inverse of cos 2 theta, right? But we know that cos 2 theta can also be written as sine of pi by 2 minus theta, isn't it? So you can see it as sine inverse of, so cos theta, can we write it as sine of pi by 2 minus 2 theta, isn't it? So since you have the same angle, but the equation we have changed it in such a way that we can easily eliminate the sine function over here. So sine inverse and sine will obviously get cancelled, and you will have pi by 2 minus 2 theta. So at y, and y dash should be minus of 2 differentiate d upon dx of tan inverse of x. So you have your answer as minus 2 upon 1 plus x square. So this is how you are going to solve all the examples in an easier way, and we can immediately find that solving inverse trigonometric functions or trigonometric functions is very easy, and also solving implicit functions is fairly easy to understand and get the answers. So in the next video, we are going to go through 5.4 exercise from the CBSE or NCERT. Thanks for watching, and see you in the next one.